Alright, in this video we'll do one last type of work energy theorem problem. So in the past we've been uh, using the net work to find the change in kinetic energy. And this time let's find the change in kinetic energy to find the net work. So let's see. Say I'm pushing a box. It seems like I've been doing that a lot recently. And I'm going to push it with 800 newtons of force for 4 meters, say. And say this box is 50 kilograms. And what I don't know is, what is the force of friction? Right, because the friction is going to go this way. It's always going to go against me. Wow, that's a horrible arrow. Wow, look how bad this is getting. Alright. Alright, you know what? I'm just going to go ahead and erase that. This is embarrassing. There we go. Alright. And we don't know what the force of friction is. But we know that, let's say that this block started out as with an initial velocity of 4 meters per second, right? Before we got to this section with maybe it's got some like grass on it or something. So before we got there, it was going at 4 meters per second, and after those 4 meters, it started going at 1.5 meters per second. And now I want to know what's the force of friction. So I have the initial and final velocities, and I have the mass, so I can find the change in kinetic energy. So the change in kinetic energy is equal to the final kinetic energy minus the initial kinetic energy, and that's going to be equal to 1/2 times 50 kilograms. So we're doing the final, so 1.5 meters per second squared minus 1/2 times 50 kilograms times 4 meters per second squared. So that's going to give me, let's see, 56.25 joules minus 400 joules, which will give us negative 300 and, there we go, 343.75 joules. So we see that the change in kinetic energy is negative, right? Which is making sense because it slowed down. It also makes sense because it means that the net work must also be equal to negative 343.75 joules, right? And that just stems because net work equals change in kinetic energy. So that means that the net work done was negative, which makes sense again, because the block must have been transferring some of its energy away to lose kinetic energy. Well, if we know that the net work is 343.75 joules, we also know that the net work has got to equal my work plus the work done by friction. So for my work, it's going to be 800 newtons times 4 meters plus the work done by friction, which is going to be negative F of force of friction times 4 meters. And this is going to all equal negative 343.75 joules. So if we subtract from both sides, we can get that the force of friction times 4 meters is equal to negative 3,543.75 joules, which means that the force of friction is equal to negative 886 newtons.